Okay. Hello, everyone. This is Intro to LLMs. I'm Liam. I've been a bunch of different things. I was the co-director for Rowdy Hacks this year, and then have done tech officer and VP and a bunch of other stuff. So I'm going to be talking a little bit about large language models. I will say I did have some slide notes through Google Slides that I thought I was going to be able to see, but I'm not because weird display stuff. So I'm going to do the best I can, but sorry if I do stumble over any words. But I'm basically going to be breaking this down into two separate parts, kind of a history of LLMs and a little bit of how they work under the hood, and then diving into a more like kind of as software engineers and computer scientists, how you can interact with these LLMs in your own projects and things like that. Some history of LLMs. I'm going to be skimming over some stuff because honestly, we would be here for hours if we talked about like literally everything that happens with like how LLMs work. But basically leading up until around, let's say like 2015 or so, there was a ton of research that's been happening since basically the dawn of computer science on natural language processing, machine learning, things like this. A ton of this work was key to getting to the point where we are today with LLMs. As much as I'm skipping over that stuff, it was incredibly important. But kind of diving into LLMs. So Google DeepMind in 2017 published their transformer architecture. They had this paper called Attention is All You Need, and it was a landmark point in kind of the development of LLMs. It arguably set us up for the course that we are on today. Pretty much every state-of-the-art model that you see today from any of these like large companies uses transformers under the hood that was based on that research. Then in 2018, Google released BERT, which was an early but influential one of these transformer-based models that focused on the understanding and representation of this text as a thing called tokens, which we'll talk about in a second. Rather than actually generate text, this model was explicitly for understanding it. So it wasn't quite the LLM that you guys know today where like you put something in and it spits something out. This was just for understanding the text that would go into the model. But really quick, what is a transformer? So transformers are kind of the building blocks in many ways of LLMs. They allow for the weighting of certain words within an input more heavily than others, allowing the model to sort of focus on the important parts of a given input. This is so that it is able to kind of generate more accurate text, and it's also able to do this in a much less compute-intensive ways than previous kind of attempts at this text generation had taken form. To do this, essentially is what they are doing is they break a kind of input it down into parts called tokens. These are typically a couple of characters long. It varies. There are tools for counting what a given how many tokens are in a given kind of input data. But it's not something that you can just like count off the top of your head. It's not like a standard kind of count. And then these LLMs are made up of these transformers, which are then added into layers, which comprise this like entire LLM. And then the transformers are composed of matrices that do math to predict tokens. I'm not going to be diving too deep into the mathematics side of things today, because once again, we would also be here for hours. There is a really good YouTube video, and I meant to add a Go link to it here, but I forgot to. But if you look up the diagramming how LLMs work, I believe it is a really good representation of how these like kind of models work. I'll post that on the Discord after this talk. And you can kind of see an example down here of, in a way, what the LLMs kind of do. It will not let me zoom in, but basically it says you have some input tokens and they go into an encoder, which encodes it down into more and more tokens essentially, and then you have a decoder which takes all that info and outputs a response. So in this case, they are kind of translating the text into other text. So continuing on our kind of history lesson here. So in 2018, OpenAI introduced GPT-1, which stands for General Pre-trained Transformer 1, a decoding-only model, similar to Google's BERT. And then in 2019, OpenAI introduced GPT-2. In many ways, this was like kind of the first like launch point of what you guys would understand to be like kind of a modern day LLM. So this one was able to basically take input tokens, so it had that reasoning on the tokens and all those kind of things, and then it was also able to output tokens, so you would get a response back. GPT-2, though, would struggle across a huge swath of the inputted text and answering, even in grammatically correct manner, like an answer that looks correct, it couldn't really consistently pull off at all. But the text was generally like, yes, that is a sentence that it is giving you back. As an example, there's this site here. I have added a Go link to this one, but it has a ton of examples about kind of the progression of OpenAI models. Really cool to see with like prompts across a huge variety of different like kind of topics. Really, it's kind of hard to actually query some of these models. Like with GPT-2, you have to actually like spin it up on a third-party provider. You can't get it out of OpenAI's API or anything like that. So it is a really neat resource to kind of see how these models have progressed over time, along with like how much they cost to train and other things. But as an example, we have this: if light behaves as a wave, then shouldn't we be able to hear it like sound waves? Which is like a pretty easy question, but the GPT-2 kind of loses the plot on it. It's like the answers to this question is more complicated than we think, and then it starts just repeating the text. The wave equation is a mathematical equation that describes the behavior of a wave a bunch of times before giving up. So continuing on, GPT-3 gets released in 2020, and this is the model that kind of starts to make some serious ground on the actually answering some things in a way that is like understandable. And generally, every time you ask it a question, it answers it in a manner that is like readable. Like you would think like there's a chance that a human could have wrote this kind of. It doesn't get into those loops that GPT-2 did where it just like gets confused as much. So it is OpenAI's also first closed source model, and it is available via the Playground and API. I'll go more into the, and it will go on later to power the first version of ChatGPT, which will be released in 2022, 2 years later. It also cost 150 times the amount that it cost to train GPT-2. So GPT-2 was like $4,600, and this was close to $700,000. Which is still a splash in the bucket because we're about to talk about GPT-4, which cost $50 million estimated to train. But GPT-3 is much better at answering questions. So we have this: if light behaves as a wave, then shouldn't you be able to hear it and, or shouldn't we be able to hear it like sound waves? And it has a much more proper response that says, you know, the sound waves are pressure waves that travel through the air, light waves are electromagnetic waves that travel through space. A really good answer. It's cohesive. It is like grammatically correct. It sounds like something that a person could have wrote. They released ChatGPT in 2022 as a research preview, which is powered by GPT-3 under the hood, and it is strong across a wide range of subjects, but it still lies, but now with a lot more confidence than GPT-2. So unlike with GPT-2, where sometimes you could read the answer that it would output and like be like, okay, I don't really buy that. You know, GPT-3 will basically lie to you like with the full confidence of like an expert. So it hallucinates, does things like that, which is kind of a downside to it, you know, always outputting something that's like grammatically correct and cohesive. It's a lot of answers that sound right, but maybe aren't inherently correct. Also, this was the first time that they presented it in this new modality of being a chat window. So I'm going to dive a little bit more in the actual like practical demo section of like what I mean by that. But essentially, before, the Playground for OpenAI would basically just have like a text window that you would basically put some text into, and then the model would go and fill out the rest of the text. So basically like a Google Doc with like autocomplete, more or less. So now we have it in a chat window where you send a message, it sends a message back, and you guys can go back and forth. Also, this really is kind of the turning point that puts AI at the forefront of the world stage. I'm sure all of you remember when like ChatGPT came out, and slowly but surely like everybody starts using it. Even people who have no interest in like anything technical began using AI, using ChatGPT. In many ways, it became like synonymous. Like it wasn't like AI, it was ChatGPT, in the same way that you would, you know, maybe call a box of tissues Kleenex. And this also, in many ways, kicked off the AI arms race. So as I talked about earlier, like Google and a bunch of these other firms were kind of doing some research, but this really like made it so that there was a ton of investment and money going into AI to figure out where this technology was going. So we have a couple of other ones. I won't dive into the histories of all these because once again, tying back to the we will be here for hours, but you have things like Claude, Meta's Llama, Google's Gemini, and Mistral. And at this point, like there's so many different AI companies going that honestly, probably even your grandma was working on an LLM. Like literally anybody and everybody. There were like vacuum cleaner companies trying to make them. It was insane, just like tons and tons of money flowing into the space. But Apple still to this day does not have a functioning one. But continuing on with the history. So basically OpenAI now goes ahead in 2023 after ChatGPT is released and releases GPT-4. This is the first model where like you're really starting to see, basically answer correctly on a ton of topics. It still hallucinates, but its ability to like kind of reason through things, work on different like kind of problems, stuff like that is really improving. And not just at OpenAI, but across different AI companies, there's a lot of breakthroughs, such as a mixture of expert models, which is essentially those layers I was talking about earlier that the models are comprised of. There are essentially layers that are somewhat isolated within the whole LLM that are experts on certain subjects. So when you basically ask a question pertaining to something, it will use those layers from that mixture of experts model to answer the question more accurately, which basically helps it not get quite so confused. So that way it isn't having to basically filter the data that you ask about a programming question through parts of the model that are more accurate about history, for example. Also, we start to get a lot more support for integrating these products into, or these models into our own like kind of systems. So this is through the form of basically all these AI companies start opening up basically APIs where you can hook up your own products into them. There's things like tooling and structured outputs. Tooling basically lets these models talk to your own services, so things like a database or a API layer, things like that, so that they can kind of integrate more closely into your products instead of you just having to like send text to them and get text back. And also things like structured outputs, so that way you can always guarantee that the model gives you back something like JSON that your code can then consume and do something with. This is also the point where we start getting multimodality in basically all state-of-the-art models. So state-of-the-art models are like generally the models that are coming from like big tech companies, Claude, OpenAI, these kind of like massive parameter models that are costing millions and millions and millions of dollars to train. And that allows it to essentially take in not just text, but also images, video, PDFs, all these things, and essentially reason across them and return things like text, but also other things. You can start to have it output things like images, files, other types of input. So essentially being able to have like a web of like all these different kinds of inputs to all these different kinds of outputs. This is kind of where we are at now. Obviously, things are progressing. We have things like reasoning models that are rapidly starting to kind of take the market. Reasoning models are where essentially the model goes and it generates a ton of text beforehand, which is called basically their chain of thought. And then they use that to answer your question more accurately. And these models are kind of what the new standard is. Things like GPT-5 are going to be a reasoning model. And this is kind of the way that the industry is moving, and they're able to answer like kind of more complex logical things way more accurately. But moving on to how can I use them? So this is where we're going to dive into more of the practical, like how can you actually use LLMs in your own projects and things like that. Kind of what I was talking about earlier, where the initial versions of GPT were in a document style thing where you put some text in and then it generates the rest of what it predicts the next text to be. We kind of still do that in many ways with chat, like with chat style interfaces. And it's something that I think a lot of people don't necessarily recognize, but LLMs don't hold like any sort of state. They don't really have any context of like the conversation that you've had, things like that. Is all they see is basically at the end of the day, when you're boiling it down to like really simple, it is just a blob of text that they are generating what they think the next most likely text to follow that is. So when you're using a kind of chat application, the loop really boiled down, if we're not paying attention to all sorts of stuff like tool calling and talking to other APIs and all this other stuff, boils down to this loop where essentially the user sends a message, you add it to any previous messages that the user or the LLM might have sent, and then the LLM generates the most likely next message. And you basically do this for infinity. This has all sorts of implications. There are a thing called context windows in LLMs, which is basically how much data they're able to look at for one given generation. And this is another area that is rapidly changing with how much text and input can you process. But not really worrying about all of that. This is the basic loop of how any AI application that you use today functions. A really good way that I like to interact with LLMs is the Vercel AI SDK. It's for JavaScript and TypeScript, but the nice thing about it is that it provides a standard interface for interacting with AI models from all sorts of different providers. So, folks like Google, Claude, Meta, Gemini, no, we already said Google, basically all these different companies will basically have their own APIs for interacting with these LLMs. You just go grab a token out of their developer console and you're ready to roll. You have to hook up a credit card and it'll cost you a pile of money, but but basically it's really easy to get started. But the kind of one issue with that is that each of them have their own implementations of these kind of APIs for interacting with LLMs. And it's kind of annoying to have to go learn each one and not be able to kind of quickly mess with them. So the Vercel AI SDK lets you have a standardized interface for interacting with them, which you can kind of see here. That means that you can basically drop in all sorts of models, play around with which one works well for your use case. Certain models like Claude are generally better at coding tasks, versus a lot of people like the personability, I believe is the word, of OpenAI's models. So you kind of just play with different ones and see which one fits your use cases best. But we have some example code over here. For how you would basically generate some text with OpenAI using the Vercel AI SDK. And you can see here that we have a messages array with a role for the user. The role can be the user, the system, or the assistant. System is what is called the basically system prompt. It's the first thing that the AI ever sees, and it kind of sets the rules for how it should behave during that interaction. Assistant is the AI responding, and user is the person talking to it. And then we also have some content that goes with that message. The type of the content is text, and we also attach a file called ai.pdf that the API is able to process and kind of use as information in that response. But the Vercel AI SDK basically makes a ton of this stuff way easier. It handles things like streaming for you. So if you've used any of these chat applications, you'll notice that when you send a message, it doesn't just give you all the text back at once. It slowly kind of fills in the kind of text. And that isn't just to feel more conversational or anything like that, or make it seem human-like. It's actually giving you back the text as soon as the model has it. So it basically generates one word at a time and slowly streams that back to you as the model completes, so that you aren't having to wait a whole 30 seconds for it to finish talking. It also has a bunch of support for different things like tools, which I'll talk about in a moment, so you can interact with your own services, and also embedded data, like you can see here, with the basically being able to send it a PDF file that it's then able to kind of include in the data that it gets to generate its response. But another way to use it, and the one that I will be demoing today, is the OpenAI SDK. It has support for Python and JavaScript, and I believe there's a couple of other languages. There's a lot of community ports. I know there's one for C#. I believe Java has one. So there's a lot of different languages that the OpenAI API SDK supports, but obviously because it's OpenAI, you can only use OpenAI models with it. And this is where I'm going to be demoing a project. So if any of you were here last year for April, ACM does an April Fool's joke every single semester. And the one that we did last year was a model that basically replicates our dear former president here, by essentially having a bunch of Discord messages that he had sent. And then we use that and we made it into a Discord bot that you're able to ask questions and it will respond to you as Josh. So how it works, and I just realized I probably shouldn't have like maximized this, but as you can see here, we have some responses from it. And you can just ping it in a message and say like, hey there, how is it going? And we give it a second and it responds back. So how does this work under the hood? The code is actually really simple, and I'm hoping that this will be a good example of like kind of how to use these AI tools and how to like integrate with them. But the first thing we have in this file is our system prompt. Once again, this is kind of how we explain what the model, how we want the bot to act. So we tell it that its name is JoshBot. It's an AI implementation of the president of ACM-U.TSA, and we tell it that we are providing it with messages that it's able to use as reference for like any sort of questions it might have, so that it can respond like Josh. You can see that here. Also, we're going to be putting the source code for this just without the messages up on GitHub, so you can kind of reference this afterwards if you are ever like kind of trying to mess around with these sort of tools. Okay. And then the next thing that we do is set up some basic like Discord stuff. That's not really what this intercheck is for, but that's what that code does. And then we instantiate this const AI variable, which is essentially, if you're like more in like the Java world and things like that, you can think of it like essentially a class that lets us interact with the OpenAI SDK, and we give it the link to our OpenAI key, which you go generate through their portal. That part is super simple. You can just like look up how to generate an OpenAI key, and it's really straightforward. Okay, and we have some other random Discord stuff, but that doesn't really matter. And then the main thing is that we have this, basically this is what we call once someone sends a message that mentions the Discord bot. And we have this runner here that we use the AI SDK, and we essentially define a couple of things. We say that we're using GPT-4 Turbo Preview as our model. These days you'll be able to add all sorts of models. We made this last April. So these days, if you were using OpenAI, you'd probably want, if it was just for fun stuff, you'd probably want to use GPT-4o, or if you were trying to do like more complicated reasoning type tasks, you would want to use something like O3 Mini. And then we also define some messages here. So these are essentially the system message that we defined above, and then also the message that we just got from the user, which we basically do some basic formatting on and add that into the messages array here as the user. We also provide it with some tools. So we say that the type of this tool is a function, which means that we're basically giving the model a function that it is able to call at any time to help it generate its response and get more data. And what this function does is get like messages, which is essentially the model will be able to pass some data to this function, basically like a search query, and it will fuzzy search all of Josh's messages to find similar messages to those kind of search queries that it gives us, which it can then reference in its response. So we tell it basically that it can expect back an array of strings that we want it to pass in. We give it a description of what it does, and then we just tell it to basically treat it like JSON. That get like messages thing is really just a function. So down here you can see we have it pass in a query, and we're using this library Fuse to do the fuzzy searching. And we just look through this whole messages array for messages that have similarity to the query that the AI model would like us to look up with. And then we just return back what we got. And then lastly, we basically just do some more handling of on message and basically just waiting for the response. And when we do get a response back from the AI model, we then send the message back as a reply in Discord. As you can see, it really is straightforward. As complicated as like it can kind of see some of these AI tools, these SDKs make it really easy to interact with them. And the OpenAI one is not just JavaScript, as I said. If you have any like proficiency in Python, Java, C#, any of these type of languages, you can find a way to use those models. And it is pretty quick and easy to use. As I said, we'll put this up on GitHub as well, so y'all are able to reference it if you do want to like kind of go play around with it or anything like that. Okay. And yeah, that is the end of the talk. Thank you all so much for attending. We have a QR code there to Portal, so you can go and get those event points before we have Banquet coming up in a few weeks. Yeah, if anyone has any questions, happy to answer them. But if not, thank you all for attending.